Alright, let's continue. Last time we learned about the concept of CD. This time we're going to learn about the concept of steps. We'll also learn about steps using the same prompt. When AI creates images, it can do so over several stages. That's what we call a step. It's also referred to as a sampling step, among other terms. A step refers to how many stages it takes to create the image you requested. As you can see, when the step is set to 4, nothing appears. Right? Let's try setting the step to 8. It's the stages involved in creating an image. For example, when you ask a child to draw a flower, they don't draw it all at once. They go through several sketches before finishing it. It's the same for AI. When drawing, as you can see, if the step is set to 8, it draws like this. Isn't it fascinating? Now, shall we try increasing the steps a bit more? If we set it to 20, we'll get the image we saw earlier. Let's try 16 and run it. So with the crucial fix now firmly set and the initial seed also meticulously fixed, we are progressively increasing the total number of steps while the fundamental seed itself consistently remains fixed. The resulting image is precisely generated at the 20th step of this process. Therefore, when we carefully set the parameter to exactly 20 steps, the specific image we originally intended and desired is successfully created. Oh, that's absolutely right, and it's quite clear now. So teacher, is 20 the maximum number of steps? No, it's not. You can keep increasing the number of steps as much as you want. So what happens to the image as the number of steps increases? The higher the number of steps, the more likely the image quality will improve. Let's try it with 28 steps. With the seed firmly fixed, we are going to clearly see how the image gradually transforms as we steadily increase the number of steps. There's a high chance that the image will improve, either with better retouching or increased sharpness. Let's try it with 50 steps. In the past, people used to say things like, use 28 steps for extracting people, 45 steps for backgrounds, 35 steps for objects, and so on, but that's all outdated now. These days, it's just for conceptual understanding. Later, when you use other templates or features, it's helpful to know why certain step values are used so you can check and understand them. When you use a certain number of steps, there isn't much change, right? There isn't much change, so let's try with 100 steps. What this means is, if you set it to 100 steps, it creates that flower over 100 iterations. So what do you think will happen to the image processing speed? It'll obviously take longer, right? It takes longer to generate because it's being made over 100 steps, so naturally the quality should be better, like a retouch. But of course there are limits to what this tool can create, so it's likely that there won't be any major changes. In some cases it might not be able to generate the image at all, or it might hit its maximum capacity and fail, so it's very likely that there won't be much change. Even with 100 steps there isn't a significant difference. In the past, when you set it to 100 steps, you would just get a yellowish blurry result. But now it seems that even just about 20 steps are enough. Within this range of checkpoints, that's what it seems to mean. So the number of steps refers to how many times the image is drawn for the seed image, but usually we just set it to 20 steps and work with that. So things like how many steps to set it to use to be discussed in papers in the past, but now it doesn't really matter. As for CFG, you can see it written here, but in my experience, the lower it is, the less the model understands the prompt. Should I say it just creates whatever it wants to make? The concept is kind of like that, I guess. What is it actually making? What could this be? It kind of just makes whatever it feels like. So the result comes out quite different from what I intended, but if you raise the CFG higher, it turns into a kind of crazy state. Now let's try setting it to 5.6. It's a bit too much, so I'll try setting it to about 4.5. For example, in the past when I gave lectures, I used to explain it like this. CFG is the degree of fidelity to my command. So it's about how faithfully it follows the command. If the CFG value is low, it disobeys my instructions. But what do you think happens if the CFG is set high? It becomes obsessively fixated. So I'll try generating with the seed set to random. The CFG itself is at 4.5. Let's try generating it. When the CFG is high, it can become obsessively fixated and create things in its own unique way. So in any case, it tries to create something that matches the intended purpose as closely as possible. The default value for CFG is usually set to 1, but I've also used it at 8. Let's try setting it to 11. You can gradually introduce more dramatic changes this way. Oh, let's just go back to the very important 111 seed again. Yes, 111. Oh, 111 fix. And the crucial CFG is... Let's try setting it to 25. Let's see what kind of monster comes out. Just by looking at it, you can tell the prompt is about to break, right? See, it broke. It's gone crazy. The AI has... Then do you think it could understand up to about 15? Let's try running it. Sometimes with certain checkpoints, the higher the CFG, the clearer and cleaner the output becomes. So I used to use those values when making videos later on, right? Like this. In my considered opinion, it's definitely better to go back to the original 8 steps and then meticulously create it with the standard default settings. Let me turn off the antivirus for a moment. Why does this keep popping up? We're back to the original state. Anyway, you can control the image with random values. That's what the K-sampler is, controlling the image. Now we're going to get familiar with the concept of sampler names and schedulers. The sampler name refers to when AI draws a picture, it can draw in various ways. A child could draw holding a brush, or with a ballpoint pen, or with a pencil, right? That's what this is like. If you look at a drawing program, there are lots of different brushes, right? It's kind of like that, but honestly, which one you use isn't all that important, you know, whether it's EMSD or something else. It's the same with the scheduler. If you pick a sampler, then you choose a processing method that fits it. If you hover your mouse over it, it shows up. Calling it a processing method sounds a bit odd. Just think of it as another fancy ballpoint pen. So if this is a ballpoint pen, this one is the basic ballpoint pen. And if you look here, this is like a super high-end ballpoint pen. That's how you can think of it. You can think of it kind of like a brand. Just think of it as that kind of difference and take it lightly with a bit of wit. There's not much point in trying to fully understand AI. So then, what happens to the image if you change the sampler and scheduler? It changes as well, of course. You can think of it as the color tone changing. That's right. The design elements change and the quality changes too. Should I try using something fancy for once? DDLM. This one wasn't used much in the past. Then there are also some fancy schedulers like the DDLM scheduler and things like S3SD as well. Besides those, I do not see some of the ones I used to like, but let us just try it with this. I will use the DDLM Uniform, which is a very high-end scheduler. The reason I call it high-end is because in the past when you change to a scheduler like this, generating an image would take a really long time. But since we are using a cloud-based service, there is actually not much difference. You can even use the GPU. Let us try it with the GPU as well. I'm not sure if it will be compatible, but something really great is being created here. This is good. All these things are helpful when producing videos, but this one breaks, right? It is not compatible. In that case, you need to change it to the Keras format. Just think of it as a difference in name or brand. If you use Keras, it should process properly. Because the uniform types are not compatible with each other. That's right. Now it processes correctly like this. In my opinion, 3M looks the prettiest. 3M seems to have come out the cleanest. And things like SGM uniform are just okay. Nothing special. Things like DDPM and so on. But the ones most commonly used are EMSD, Keras EMSD, and 3MSD. These types have been used a lot. Back in the day, we used to... So, what you can understand here is that whenever you change the sampler or the schedule, even with the same seed, the feel of the image changes. That's something we've been able to figure out. Next, every time you adjust the CFG, you can check how faithfully the prompt is being followed, or see how the way the image is controlled changes a bit. It's explained very clearly here. That's excellent. If you increase the steps here, it's very likely that the texture and other detailed elements will improve even more, right? Great. So that's how we've created the image. Now next, here is the latent image for the radio, but I'm not sure why they're using a latent image for this. Anyway, you see it's set to 510 by 510. If I were to try setting it to 2000 by 2000, let's go ahead and click run. If the blank latent image is 2000 by 2000, how will the image be generated? Let's take a look. You can tell right away that something suspicious is coming up, right? What on earth is that supposed to be? You can't really tell if it's a rose or something else, can you? A latent image refers to the ratio in size. For example, let's say I need it to be 2000 pixels, because our company needs to work with 2000 pixels. But when I generate it at 2000 pixels, the result comes out completely different from what I put in the prompt. Why is that? Why do you think that happens? This is really important. Right now there are, what, 1, 2, 3, 4, 5, 6 flowers that have appeared. Huh? Why on earth is that happening? Huh? Then this time, should I try entering 1000 instead? 1000. Should I try entering 1000? AI isn't a human, you know. AI works based on what it has learned. So basically it learns first. The AI does, right? But what does it learn from? Here's something even more important. In what format is it trained? That's the key. Usually when we train AI within a checkpoint, we do it within a 500 pixel format. 500 pixels. So actually the AI produces the most stable results at resolutions below 1000 pixels. Below 1000 pixels. But if you go just over 1000 pixels, like 1500 pixels or so, and try it out, then what kind of problem does this cause? Let's say the AI learned an image at 500 pixels. Now, if you set it to 1500 pixels, since the size has increased, it's as if the AI thinks it needs to create multiple images at that size. So if you imagine a single flower at 500 pixels, at 1500 pixels, you end up with several flowers appearing in the image. That's right. This is how you lose control over the output. Shall we go back to 500 pixels? Then of course you'll get a single flower. Usually when training images, you train them between 500 and 1000 pixels, so if you set it to under 1000, you'll get a single flower, right? But as the size increases, the pixel dimensions naturally get larger too, so you end up with multiple images. This used to be a problem with AI in the past, so what would happen if it were a human? If I were to generate a person, and I didn't know any better, thinking, I need 2000 pixels, so I'll just generate 2000 pixels, then you'd end up with things like 8 arms and 8 heads attached. That's the kind of phenomenon that used to happen. If you understand this concept, you'll have a pretty high level of understanding about AI, so when you're working, you won't need to question why things are done to certain specifications. Instead, you'll be able to recognize, oh, that's why they did it this way. It's not just because of the generation speed that things are done this way. Thank you. The specifications are determined and the work is done according to the amount of training of this checkpoint. You need to be well aware of these concepts when you work. This time we've learned about the K-sample part. Let's wrap up and move on to the next part.